I'd now like to do some examples of multiplying and dividing values while also considering the significant digits. When multiplying or dividing, multiply or divide, then round off the answer to the least number of significant digits contained in the question. This is what we've done before. Now the new one is, when multiplying or dividing an uncertain value by an exact number, the answer has the same number of decimal places as the value with uncertainty. So this 3 here is a certain value. We know this exact number is 3. Like, we're tripling whatever your mass is of 5.2. Your result is going to have the same number of decimal places as the original value. So here you get 5.2. The result is 15.6, the same number of decimal places. Now also keep in mind on C, you see when multiplying or dividing a value with uncertainty in order to use a different prefix, so going from here, we're trying to go from grams to milligrams, the original significant digits are retained identically. We can see here that 0.030 has 2 significant digits. This result here should be 30 point, showing that it has 2 significant digits. So looking at some examples I've already done, this first one is a unit conversion. We're going from milliliters to liters. So I notice 1, 2, 3 significant digits. My result has 3 significant digits. This second one is following the first rule because these are just 2 measured values. This is a mass and this is a density. I notice that my top number has 3 significant digits and this one has 2. So I need my final answer to have only 2 significant digits, so I must round to the nearest tenth in this problem. For this next example, number 3, we can see that 6.7 times 2.4 times 1.3 is actually 20.904. These all have 2 significant digits, so my result needs to have 2 significant digits, so we get 21 centimeters. If even one of these had more, it doesn't matter, it's the least amount of significant digits. So in this case, they all have 2, so 2. In number 4, we're using our second rule, where we're multiplying by an exact value. Notice we have 2 decimal places in this value. When I multiply by the exact value, I need to have the same number of decimal places as the original, so we've got 2 decimal places here. Here we have another unit conversion, number 5. We want to go from centimeters to millimeters. So here I just retained the same number of significant digits in both situations, 3 and 3. Here we have a density times a volume. So these are both measured values. We have 3 and 2, so I had to round this to 2 significant digits. Here in number 7, we have a unit conversion. It's not written quite like the other ones here, but it's still going from centimeters to meters. So I just retain the same number of significant digits as the original. So here I have 4, I keep it with 4. Moving on to 8, we've got 1.2 times 10 to the negative 4 times 3.02 times 10 to the negative 23. These are the significant digits. The times 10 part doesn't count towards significant digits, so we have 2 and 3. So I need to have my final answer with 2. So even though I have all this, I need to round to the nearest tenth so that I get 2 significant digits. This one here, we have 3 significant digits, 2 significant digits, so I need to round it to 2 significant digits. Here I have a unit conversion finally for number 10, and I see that I have 2, so I get 2 here. All right, thank you very much.